Somewhere between 2 and 3 million people got a phishing text last year, and the copy was good enough that a lot of them clicked. That's not a hypothetical from a threat model white paper. That's a number from a federal lawsuit that Google filed in June 2026 in a U.S. district court against a named Chinese cybercrime network. The complaint has exhibits, it has operational details, it has a kill chain. And at the center of it is Gemini, Google's own model, being used through the API to generate phishing SMS messages at industrial volume. Now, the AI safety conversation we usually have is about alignment. Will a model do something it shouldn't if you ask it the right way? Do guardrails hold under adversarial prompting? Is the model itself the threat? And that's a real conversation. But this case is about something different. The criminals here weren't jailbreaking anything. They weren't clever prompt engineers hunting for refusal bypasses. They built a workflow. They treated Gemini like a production dependency, and 2.5 million texts got out the door before the operation got litigated. So the question I want to sit with tonight isn't whether AI can be misused. Obviously it can. The question is what professional, industrialized misuse actually looks like in practice, why the guardrails that exist didn't catch it at scale, and what that means for anyone building on an LLM API right now. To understand why this worked, you have to understand how SMS phishing used to fail. For years, the easiest way to spot a smishing text, which is just phishing delivered by SMS, was the language. The messages were stiff, the grammar was off. There'd be a weird article or a tense that felt wrong, or the register would swing from formal to casual inside a single sentence. That's because generating large quantities of convincing, native-sounding English at scale used to be hard, and that friction was doing real security work, quietly, for a long time. Large language models remove that friction completely. An LLM can produce grammatically fluent, contextually appropriate, tonally consistent English in whatever register you want, as many times as you ask, for fractions of a cent per output. If you want a text that sounds like a toll authority, or a bank, or a package carrier, you describe it, you iterate on the prompt a few times, and you have a template that will fool people who know to look for bad English because there isn't any. And that's the underlying shift this case illustrates. It's not that Gemini did something surprising or outside its design. It did exactly what a text generation API does. The criminals understood that better than most practitioners have been willing to say out loud. LLMs commoditize persuasive writing. That's mostly a good thing. It also means any operation that previously needed skilled human copywriters to produce convincing fraudulent content at scale now needs an API key and some prompt engineering. The historical defense, the bad English heuristic, is gone. What the security community hasn't fully reckoned with is that it was load-bearing. So let's walk through what the operation actually looked like based on what's in the complaint. According to Google's filing, the defendants accessed the Gemini API, used it to generate large volumes of phishing SMS content, and deployed that content through SMS distribution infrastructure targeting victims in the United States. The texts impersonated legitimate organizations. Toll collection agencies were one category, the kind of text you'd actually expect from a government service, carrying real urgency and credible formatting. Hundreds of thousands of people were harmed. What makes this a useful case study is the pipeline structure. This wasn't someone typing prompts into a chat interface and copy-pasting the output. The complaint describes an engineered operation, API access, content generation, message distribution, victim conversion. Each step automated, each step optimized. The humans in the loop were managing the system, not doing the work the system was doing. That's a meaningful distinction. The criminal labor here was in the architecture, not the execution. Think about what that means for detection. Traditional fraud operations have human-paced throughput. There's a ceiling on how many convincing messages a team of writers can produce in a day. An API-backed pipeline doesn't have that ceiling. The throughput scales with compute budget, not headcount. So by the time the volume triggers anomaly detection, the damage is already substantial. Google's guardrails did flag some content during the operation. That detail is actually in the complaint. The defendants iterated around those flags. They adjusted prompts, they found formulations that cleared the filters, and they kept going. Which is the other piece of this that practitioners should sit with. The guardrail interaction became a feedback loop. Every refusal was information about what to avoid next. The criminals weren't stymied by safety measures, they were trained by them. Now, there's a real version of this is just a tool defense, and it deserves a fair hearing before we dismiss it. Gemini wasn't designed to send phishing texts. The API has terms of service. Google did have content filters in place, and some of those filters caught some of what this operation was producing. The argument goes, you can't hold a hammer manufacturer liable because someone used a hammer to break a window. The platform provided a general-purpose tool, it deployed reasonable safeguards, and a determined criminal operation found ways around them. That's a law enforcement problem and a regulatory problem, not a platform design failure. And honestly, I think there's something to that. The specific framing I'd push back on is reasonable safeguards. What counts as reasonable when your API can generate 2.5 million outputs before detection? Consumer-grade content moderation, which is basically what most LLM safety layers are, is calibrated for individual users doing individual things. It's not calibrated for pipeline-scale abuse where the adversary has time and incentive to AAB test their way around every filter. So the hammer analogy only goes so far. This isn't one hammer used badly, it's a hammer factory that someone quietly ran for criminal production. At that scale, the question of whether the tool manufacturer bears some responsibility genuinely doesn't have an obvious answer, and courts are going to be working through it for years. So here's where I land after sitting with this one. The structural problem is that every lab shipping an LLM API is now in the persuasive text generation business, whether they frame it that way or not. And persuasive text generation at scale is a capability that professional fraud operations have wanted for decades. The barrier used to be human labor. It isn't anymore. That doesn't mean APIs shouldn't exist, or that the answer is to shut down public model access. The same capability that powers a criminal phishing pipeline also powers small businesses writing their first email sequence and non-native English speakers communicating professionally for the first time. The capability is genuinely dual use in a way that's much harder to separate than, say, a specific synthesis route for a chemical weapon. But I think this case forces a more honest conversation about what responsible API design means when your adversary isn't a curious teenager trying to get the model to say something edgy. It means behavioral monitoring at the account and throughput level, not just the content level. It means anomaly detection that asks why this account is generating 10,000 variations of the same short message. It means treating high-volume generation of short persuasive text as a specific risk profile that warrants specific controls. And it probably means that we have content filters is not a sufficient answer in a courtroom. This lawsuit is going to establish what sufficient looks like one way or another. If you're building on an LLM API right now, here's what this lawsuit means practically. Your abuse monitoring isn't just a safety checkbox, it's a legal exposure. This case is going to define what courts consider reasonable safeguards for API providers. And if you're an API provider, you should be paying attention to how Google argues its defense, because those arguments are going to become the de facto standard. If you're a practitioner building applications on top of these APIs, the question of downstream misuse of your integration is now something you should have a written answer to, because "I didn't think about it" is a worse answer than it used to be. Watch the complaint progress, watch how Google characterizes its detection capabilities, and watch how the court rules on platform responsibility. That ruling is coming, and it'll matter. That's your evening context. See you tomorrow.